This is a pretty next level question on ratio and very hard if you've never seen it before. It's normally taught later on in school, to be honest. Even like, it's normally on a GCSE paper near the end. But we're going to do it. So we've got the ratio is 4 to 5, and then we're taking out a pen and replacing it by a pencil to get 7 to 8. Now, what you have to be really careful of in ratio is you can't just you can't just have 4 to 5 and then minus 1 and add 1 to it, because this is a ratio. It's not the number of things, which is a bit of a hint, really, because how we have to write it is so it is the number of things. So it could be 4 pencils, 5 pens, or it could be 8 and 10, any multiple of these things, which is the clue, because that means it must be in the form 4x to 5x, where these are actually now the number of pens and the number, sorry, that's the number of pencils and the number of pens. So if we take out a pen and replace it with a pencil, we're going to have one more pencil. So it's going to become 4x plus 1 after doing that. And taking out a pen means we're going to have the 5x and we're going to subtract 1 from it. And now this is equal to 7 to 8. So that's the first crucial bit in this question that you can do that. What we've created is a ratio equation, which is, not easy to solve by just first looking at it. You can't equate this and this, for example, because one is a simplified ratio on the right and one is actually the number of things on the left. So you can't set them equal. But what you can do is link them together. For example, 3 to 5 is equal to 6 to 10. Now you can see that I'm timesing this one by 2 and I'm timesing this one by 2. But to get the scale factor, you can actually do 6 divided by 3. The one on the right divided by the one on the left. That tells you what you times them by. But you can do exactly the same with the ones on the right. 10 divided by 5 would also give 2. And what I'm trying to show you is how we can go from a ratio equation to a fractional equation. We can do exactly the same here, except I'm going to do the left ones divided by this one here divided by this one, because it makes sense to keep, it doesn't matter, I could swap these around and have 3 over 6 is 5 over 10, same thing. So it makes sense to have x on the top rather than the bottom, although it doesn't actually matter. So 4x plus 1 over 7 equals 5x minus 1 over 8. This is far more abstract than looking at my simple number case, but it's the same idea. It's what I am basically timesing or dividing by, which depends which you put on the top and the bottom, to get from here to here. So that is absolutely fine. You could also, by the way, do 3 over 5 equals 6 over 10. You can divide the 2 on the left together and the 2 on the right together. That will also give you a possible equation. Here it would be 0.6. We could do 4x plus 1 over 5x minus 1 equals 7 over 8. That's actually what the answers do. But I prefer to have it like this, with x's on the on the top of the numerators and then just the numbers on the bottom. Okay, we've got a fractional, so that's cool. That's a tough, second step. Right, finally, got a fractional equation with x on both sides. To deal with this, we cross multiply, or in other words, we times both sides by 8, which means I'm going to get 8 4x plus 1 over 7 equals 8 5x. Notice I only times the top by 8 here because I'm timesing both sides. Like when you times a fraction by a number, you just times the top. And actually these cancel. That is exactly why I did that. And I times both sides by 7. I'm going to put 7 over here and a 7 over here. And now these two 7s cancel. And that's what I mean by cross multiplying. You basically multiply this side, this top bit by 8 and this top bit by 7. But that's why it works, because we are actually timesing both sides. Okay, now we've got an equation involving x on both sides with brackets. I'm going to multiply out the brackets. By the way, there isn't really a quick way to do this algebraically. Of course, you could just do trial and error, but we want a method that's going to work every time and be efficient. And when you practice this and get confident at it, it's pretty quick. Okay, I've multiplied it out. I'm going to minus 32x from both sides. So 8 is equal to 3x minus 7. Add 7 to both sides. 3x is 15. So x is equal to 5. Now, we're actually asked for the total number at the start or at the end. It doesn't really matter. And that is going to be this amount here. Or the total number is actually going to be 9x. So remember, we've got the X is 5, and so the final answer is that there were 45 pencils and pens at the start and at the end, because remember, one is just being replaced. Well done.